So we can find the areas of non-perfect squares, these diagonal squares here, by drawing in these vertical lines, okay, then they have to follow the grid lines, and these horizontal lines, and again, they have to follow the grid line. And what that allows us to do is break it up into nice shapes. So we have this nice square shape in the middle, and these right triangles on the outside. And not only that, because of the square symmetry, all four right triangles are going to be the exact same shape. Okay, so they'll be the exact same area. And the other thing I want you to notice is that the length of the square edge is actually something to do with this right triangle here. This is going to be this bottom length minus the shorter length. So the long length minus the short length, we'll just say is A minus B. Okay, so this long length is A, the short length is B. We'll say A minus B. In that the length of the side length of the square is this A minus B length. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so it's going to be 14 minus 4, so it's going to be a 10 by 10. So there's 100 squares in there. Okay, it's going to be 4 by 14. Okay, so that length is going to be 4 and 14. So 4 times 14 divided by 2 gives me an area of 28 squares in there. There's 28 squares in here, 28 in here, 28 in here. So when I add that all up, I'm going to end up with, what is that, 4 times 28, which is 112 plus 100. So I get this total area is equal to 212 squares. Okay, so what ends up happening then is the side length. We want to find the side length as well. The side length here, well, if I have the square area, I can go from area to side length by squaring and square rooting. So I'm going to take the square root of that side of the area. Okay, and the square root means I get the side length. Okay, so I do square root 212, and I end up with 14.56 approximately. So this is about approximately 14.56 length. Okay, so the key then is to be able to break up these diagonal squares into the right triangles and the square in the middle. So again, we want to draw in straight down, and we have to follow the grid lines all the way to the corner. And then we'll go across from the corner. Okay, and then again from the corner, we're going to go across. And then from the corner, we're going to go across again. So when we calculate the areas, okay, and let's figure out what this right triangle is. This is 3. This right triangle has a length of 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 3 by 10. Okay, so this length in here is going to be 7 by 7 square. So we're going to end up with 49 in here. 3 times 10 divided by 2 gives me the 15 squares in each of the triangles. Okay, so there's 15 squares in each of the right triangles. I add this all up. I get the total area here. Works out to be 109 squares. So the side length then works out to be the square root of 109. Okay, so that's the exact side length. Square rooting gives me side length. And if I work out the decimal, it's approximately 10.44. Okay, so that's approximately 10.44, and that's units. Okay, and this would be units squared. This would be units squared, units, and this is units squared. Oops, sorry, this is not units squared. That's just going to be 10.44 as the length. Okay, so again, the key is then to generate this right triangle and this square, and this square is related to the sides of this right triangle, so 3 and 10. So the sides of the right triangle have something to do with this, helping us calculate this area. Okay, so we're going to practice a few of these. Okay, make sure that you're able to draw these in and generate these areas because it's going to be important for another part of the unit as well.